don't have too much on our plate today. There's only a cooling rate comment here. Who's responsible for this?
So Lindsay raised the issue, and Sean Walker after that agreed that it was a bit of like a mystery for him for a while until he figured out like the name was not explicit enough for him.
Doug was suggesting that.
Yes,
okay.
I could not figure it out.
Yeah. I just saw Lindsay.
No, well, I just contacted Lindsay, and then she actually posted the issue. Doesn't matter. The main thing is that we now have something that is understandable.
Mm-hmm. Well, I kind of like the N meter per beta naming. Yeah, I'm fine with that.
It tells what it is.
It's more clear. I agree.
And Doug was mentioning, what was that, beta not ratio? Better wording?
Oh, yeah. Not really. Yeah, I don't have a route through that one. What?
For should say it's for the directive. Is that what it is?
Yeah.
Yeah. So beta schedule.
But I'm not 100% sure how that is evaluated. How do you evaluate that initial beta?
I think Thibault can answer it because Thibault spent quite a bit of time, I guess.
So it's making a very rough estimation of the biggest eigenvalue of the data misfit and the regularization function. And after that, you like the beta ratio is basically saying it's basically say if you want it to be 10 times the ratio of those two biggest eigenvalues.
So how do you do? How do you do an eigenvalue for the?
So the way it does it actually, it's actually like it's like you take a random vector, and you compare the two second derivative with multiply by that vector. So actually, for me, what I did, for example, is that like as a vector random, it's like if you do it many times, it's gonna give you a better and better estimate. It's kind of like you're sampling the probability function of that function, but and basically like if you take like what you hope is that like this eigenvalue is gonna be basically the mean of all that sampling. But here we just, I think like in the current version, only do it once.
So you just do one.
Library set how many times I want to initialize it, how many samples do I want to actually sample it. It's more stable, but and that's the way it was like. So it's called the Raylight estimation. So you can find the information about that on Wikipedia, for example.
Yeah. Well, I mean we've implemented this in some fashion or other ever since the magnetics papers.
Yes.
But still, it's it's always a matter of knowing what is actually being implemented. So that is how it's being done here. And then for the data, did you use the estimate of J transpose J, or
for what?
Well, you've got two norms, right?
Yeah.
If you did fields with the current model, the starting model.
Yeah.
Oh, okay.
And the uncertainties are inside these.
Okay. Okay, so we just need kind of nice to have a more identifying word for what beta naught ratio is, but I can't think of it. Maybe we just think about it for, keep it open just for a second, but are people happy with that?
I'm fine with that one.
I think in the same line of thoughts of this guy, we should have something that is probably more English spelled out what it is.
Yeah, I don't have like a idea right now on top of my head that would be good, but yeah. Fine in one way or the other for me.
Yeah, and then the cooling rate is here.
Yes.
Right.
So, and this one would be easy to change. You just look for all the cooling rate in the SimPEG repository, and to find it also in the example, etc., and change it for that, and change it for the new name.
Exactly. Okay. Anyone else has something to say? Want to talk about? Pretty small group, so the floor is open.
I don't know. I'm working on mostly inversion course at the moment, but I was actually helping Mike. Mike wants to do a grounded source EM inversion. So it's basically same setup with DC, but rather than using DC code, he wants to use EM code. So it requires a bit of functionality, additional sources and receiver. We're getting there. So Mike worked on the line integration code. So we got a draft code for Octree. I'm going to work on the receiver class so that you can do the actually same experiment, having some sort of finite length of dipole or bipole for a source and receiver. And we're going to implement that in the frequency domain code first. But once that's done and checked, we can extend to time domain code. I'm not sure other people are interested or not, but that's what I'm working on.
Excellent job. So what's missing is just Joe to be able to give you access to some of the underlying functions that we're missing.
So for now, we need to make a bit of assumption where, okay, if the cells along the path should be uniform. Well, I'm not sure what's exactly the uniform, but the cell size should be same. But it'll be great because that's only reason why we did it, because we extend the tensor code. So the assumption made in the tensor was need to be satisfied. But it'll be great if you can really generalize that for the Octree code. So Mike is kind of interacting with Joe, so hopefully Joe can help. Couple of Octree details, then that code could be complete.
Sounded like he had some good ideas about that.
Oh,
Right.
Mike was there. Oh, good. I thought you weren't there.
Let's turn the camera.
There's Mike.
Perfect. Yeah, and related to that, so SJ Geophysics, what was that? What was his name? Kalen. Hello. Can you guys hear me?
I can hear you, but that's
Yeah, I think they are gone. Maybe.
must be them. Yeah.
Yeah, not.
Oh,
Oh,
here we go.
Here we go. Perfect. um,
Oh, it might be frozen again.
so how's it going, John?
Oh yeah, I guess it's just us. Oh, weird. Usually their connection's pretty solid.
Yeah, not sure what's going on.
Oh, hello?
Hello?
Hello, do you hear us?
Yeah.
Oh, there we go.
I think we were lost you guys at one point. Not sure what happened.
So you hear us now?
It's all good. Yeah.
Yeah, all good.
Okay.
Yeah, so I'm just going to make a comment. So the problem that you're just talking about, namely working in time domain with grounded sources and integrating over the length of the wire, that would also be something that would be of interest to John and SJ, right?
I was like yeah, correct. But I was thinking about a little bit like a differently for SJ, they want an inductive source. So what I was approaching I was like planning to approach rather than going that route. I was actually thinking about like writing an analytic vector potential function for that. Because there's some benefits for that for an inductive source. You can make a divergence-free magnetic field, at least for an initial condition. So that was a route that I was thinking. But yeah, we can use both.
But part of what you were doing was for the receiver class, right? In which case you need to then integrate. I thought you were trying to integrate over the lengths of the wire and that you were concerned about having the same cell size along that wire, right? I mean, so that's going to happen whether you got an inductive source or a galvanic source.
Right, but if you think about the reciprocity, because like once you got a source function, that's just a transpose. So once you got a source, like if you can generate the integrated source, you're good to go. It's like an adjoint function. So
okay.
you can just transpose it. So once you got a source function, you're good to go.
Okay.
So Mike, that's what I meant. So once we develop a code that can integrate a path, then like it works for both transmitter and receiver.
Makes sense. Yeah.
Sounds good. John, do you have anything you would like to tell us about what you're working on?
Right now, I haven't gotten to the forward modeling and stuff yet for the gradiometry. Yeah, I kind of had some other side project here, some R&D stuff to take care of. I guess one thing that we're looking to maybe do, say for MT, the way that the code forward models right now, does it just assume one location for the electric field measurement, or does it actually take in a dipole?
It's a point. It's a point.
It's just a point? Oh, okay. Has there been people who have done it before where they actually model with the dipole?
Not in SimPEG, but maybe like a latest Octree code does it. Is that right, Dev?
Yes. Yeah.
Oh, cool. Yeah, I might, once I get done these few projects, I might be getting into a little bit more discussion about that then.
Yeah, that can turn out to be pretty important when you're doing kind of near surface types of studies. And, you know, if you got lateral heterogeneity and you've got, you know, one electrode for potential on one side of the contact and another electrode on the other side, can throw you up, make things a bit difficult. So yeah, you actually need to be able to integrate along that whole path.
Okay, nice. Yeah, that was one of the requests by Glenn there. He was wondering if we could maybe do that for those very reasons.
Yeah, so that is definitely on the drawing books. It has been for some time, but it's a little bit second order at this point. But maybe for some of the things that Soggy's just been doing with respect to, you know, again, integrating along a wire path for both in the time and the frequency domain, a lot of those should be completely transferable.
Oh, cool.
Right. So Mike, that's exactly same code. So once we develop this, like we can use in a various places.
That's cool. Nice.
All good. And John, you managed to, you're all good for the DC version, right? You had issue with the tree mesh?
Sorry, Don?
You solved your issues inverting that again with tree mesh?
Yeah, it's all running now again. It was kind of the first one was I was using just a bad data set. I didn't have a good discretization, and as soon as I put in a data set that I have a really good DEM, yeah, everything just started working. And then after compiling as well, everything went really well. So yeah, we're all good.
Perfect.
Dom, for that, like a mesh builders and refine XYZ function, that's actually great. And do you have any plan for extending to a quad tree? Well, it's not. I'm not sure what's like. Is that an extending or not? But it's only working for octree now, right?
Let me double check. I think I did it for 2D as well, but I'll double check. So I'm pretty sure it's already good to go for 2D, but I'll check.
Yeah, because then we can put that mesh building function in a 2D DC code. Well, 2.5D DC code.
Yeah.
Then it's actually like then DC packages kind of complete.
Did you push your, you had a mod, right, that you did, you were talking about last week. Did you push it? I didn't see anything.
No. Although I pushed in, so there's a bit of bug for origin. So I pushed in the discretized branch, not a SimPEG branch. So it seems like that the mesh building and refine octree function is in both sides. Like it's in a discretized and also in a SimPEG. So
well, it's on my personal branch, but it's not going to be on master, right?
Yeah, on the refine tree where you started pushing yesterday.
Okay, so you pushed on the discretized. Yeah, that's good.
right.
Is that what we were talking about?
No.
Because that was just the X naught, right, that you pushed.
Right. Like that's what I did push. I haven't pushed the other modification that I made to just handle like a different octree levels.
That's great. So yeah, if you want to push it first, I'll check for the quad tree, and then we'll finish that pull request.
So is that on a discretized or?
Yeah, it's the feature refine.
Is that I think the function seems
right?
like not exactly same. Is that same? Is that exact?
No, I'm trying to rename things because here, like commented, and
So
yeah,
what is the
things.
latest like function? Is that one in the discretized or one in your branch on SimPEG?
The one on discretized should be the one that we start using, because that's the one that we'll keep.
Okay.
Discretized.
So I'll focus on discretized then. Okay. Great. Yeah, so let me know if you already have the. I think as far as I was reading the code, it seems like there's it wasn't for quad tree, I guess. But let me know if you like you actually like a kind of you took account that quad tree case.
Sounds good, man. I'll do that. Okay. Anything else? Are we doing a short meeting this week?
I noticed. I just heard an idea here. Just maybe if you want to have like give 1 or 2 more minutes. I know she pushed a lot on in the issues during the weekend. Or I don't know if there are things that concerns us, or like what are the state of the pull requests at the moment.
Right. I think what she did, like she just kind of closed all the issues. I guess that's what she did.
Yes, he was closing around like there is the thing that Sean Walker also posted for, but it was like for the Gauss Newton thing. So like, I'm not sure if you were ever using that minimization routine.
Yeah, I'm not sure how to look for it, but Lindsay, I guess, can update us next week once she's back online.
And what are the pull requests at the moment? Okay, yeah.
This one needs to be done, yeah.
Yeah, needs to happen. But we already dropped Python 2.7 on Redis, so we test something anymore. This one is really more, I think, something like all the small snippets of code, like import from future, import, etc., like working up of the code.
Okay.
So it actually breaks, yeah. This pull request breaks.
So I just got a quick question about the mesh interpolation function for Octree.
Yeah.
So what are the status now? Can we let's say I got a global Octree mesh.
Yeah.
And then have let's say 100 local mesh, for instance.
Yeah.
How do you interpolate? Is that the same way that UBC Octree code does? Kind of the global domain is actually same, and then you kind of you find because you know all the parents and child cell, so you kind of it's actually the same mesh, and then you do some sort of a very efficient interpolation. Is that what you do? Is that same?
We'll need. I had to do a little workaround, but yeah, it's the same, but it's not as efficient as it should be. We need Joe to give us access to the parents from the outside of C++, but it's the same. Yeah, so the cells are all collocated, and we're just looking for overlaps between the local and global.
Okay, but
just put an update today because we were missing some of the overlapping cells. So if you want to start working on this, I would suggest you refresh the tile map.
Okay. And do I have to do it, or let's say I don't want that? Okay, I don't want exact co-located cells. Let's say I have tensor global mesh.
Yeah.
And I have an Octree local mesh, for instance. Okay.
Yeah, no problem.
Can I handle it?
Yeah, you can do Octree to tensor. Yeah.
Okay, I see.
It's just a different. I'll shoot a script 1 second. So it's in maps.
Mm-hmm.
So it's just a projectile matrix here. It depends if your global is a tree or if it's a tensor, and it does it use a KD tree.
Ah, okay.
It's a tensor.
Gotcha.
Otherwise, it just looks for overlapping cells.
Right. Do you have a function do you have a? Because I was thinking about that, and generating every time that the interpolation matrix could be pretty expensive.
It's not too bad because the containing cell function is C++, and that's really fast.
Oh, okay.
Yeah. If you use KD tree, if you go from Octree to tensor, that one is a bit slower, yeah.
Right.
Because you need to generate the trees every time.
I see. Okay. Sounds good.
Yeah, you use the KD tree from SciPy, that's right?
Yeah. It's fast, but if the mesh is really big, they take time to build. Yeah.
Yes. But you need to build it every time, or you stop it?
I flush it because it takes a lot of space.
Okay.
Yeah, and then the memory starts building up. If you have 100 local meshes, then you need 100 trees, and they start building up. Yeah.
I use it a bit, but I don't change the mesh, so I still read it, so that's the same.
Because once you build your interpolator matrix, it's a sparse matrix, and then you don't need anything else. You can just ditch it.
Perfect. Yeah.
We can go over it again, if you want to go in details.
Yeah, sounds good. Sounds good. I think that's actually enough at the moment. I can take a look at the code.
Lindsay's here.
Hello.
Hello, hello. Sorry, I'm late.
Would you like to tell us more about your cleanup, the spring cleanup that you did this weekend?
Oh, I didn't do tons, but just went through and started closing a few issues. So some stuff that had just been open for a really long time that we hadn't touched or that had changed in scope. So the criteria I used just for those handful were, it was completely out of date. Wasn't necessarily fleshed out enough. It was just like, there were quite a few that were a one statement of we should do something, which at this point, if it's 3 years old and we should do it, we can close it and like rethink things. So if there's an issue that I closed that you were on that you feel is still important, like please reopen it. My intention is not to like, take down items because they're not important, but if there hasn't been noise on it for a while, then yeah, I closed it because I figure the conversation has moved on at this point.
Sounds good. Clean up, yeah. That brings us to 92 issues. That's
So I just closed a few. I mean, if there's others, like it would be great if people too, if you'd be willing to go back and look at issues that you created. Like I just tried starting on the last page. And if people could today even just spend 15 minutes looking at the issue list, and if there's something that you posted that is out of date or no longer relevant, or is a one sentence, we should do a thing, either flesh it out a bit more and like give some pointers or close it for now.
Okay.
Yeah, because that'll hopefully help us like triage stuff a bit better in the future.
sounds good. Anything else you want to talk about?
Only other things, we opened a couple issues just based on Doug and Soggy's work prepping for next week. And so if there's issues, like we brought up the one about the terminology around cooling rate. And there's a couple other things with like directives. I mean, the fact that we don't print out the last iteration, I don't actually think we made an issue on this. But when you're running an inversion, we don't actually print out like the last iteration or why the inversion stopped. Like, I mean, if we've reached the target misfit, it would be great if at the end of the inversion, it says stopped because we reached the target misfit, just to give the user some really clear indication of like why we've stopped running the inversion would be helpful. So that's not actually an issue yet, but we can document a handful of those types of things. And Soggy, I don't know, do you have comments with respect to that as well?
Yeah, that's the major one. I think. Right. Yeah, that's the major one, which is actually quite confusing. And yeah, getting rid of like a 0.5. We talked about that. Yeah, those are the main thing.
I guess the other thing on a kind of a longer term basis, and I think this, for me, this is useful for any of the inversions, and that is to break out all of the the values of the components of the different pieces of the objective functions and all of the tree multipliers, just so that you can see how big everything is when we've finished it.
Yeah, no, I think that's a really good point and fits in. We need to start refactoring some of the directives so that they are based on properties and are serializable and all that sort of stuff. And this fits in appropriately in the scope of that.
Totally agree. Yeah, we have those saved dictionary, and then they're all different. They all output different things.
Yeah, and we really don't want to be writing ASCII files. Like that's because everyone creates their own standard for an ASCII file, which is really not helpful. So if we can do something like with properties, and then if you want some beautifully printed version, then like we should be able to translate between them. But the thing that we save should not be an ASCII file.
Yeah, totally. And then, as Doug said, have one that breaks apart each component, with like keywords or whatnot.
In some ways, I think like so that it would be nice if we took another look at the iteration printers. Rowan put a lot of thought into that originally, and there's some cool ideas in there. But it would be great if like you could just basically, when you're running the optimization or when we're getting ready to run the inversion, provide keywords of just like what are the things that you want printed. So if you want every component of the objective function or of the regularization printed independently, like we should be able to do that. If you just want to look at phi-d and phi-m, we should also support that. So that like for some of these education examples, like we don't want to overwhelm people with information right away. So it would be nice to be able to selectively expose what's being printed.
And even turn them off if if you don't want to have any print to screen yet.
Yeah.
That would be nice.
Yeah. Does somebody want to start? I know, Dom, you've given a bit of thought to this. Do we have an issue going, or would somebody be willing to sort of start just outlining some of the things that you see from your perspective as being necessary?
I can start an issue, yeah. Sure.
That'd be great.
I know that on my branch, those save function are heavily modified, so I might contribute to that thing to like go back to what I did for my own case.
Just have one that does it all, and then we agree on the output, and then that's it. I mean, yeah, Psych did a good job with this one. It's a pretty long one. There's a plotting function also in it.
Yeah, so I mean, they're actually like you can get all the information, like different components. Not like I think that's for TechNav case, I guess, but
we can take the best of each.
Yeah.
Yeah, those plotting function are handy. I know I added more option on my branch to that. Maybe I could like pass that out and just make a small pull request for those update. Like being able to plot every single like the option I added was to be able to plot every single component independently, like either phi-m, but also like the smallness and each smoothness individually, stuff like that.
Right.
And I know that those plotting functions too, there are some things like we see like on top of that, this one like the self.target misfit. It's a very useful information to have, and unfortunately right now, like that property is instantiated in the plotting function. So if you want to have access to that, you need to have plot the function before, when it's not required by, like you don't require to plot it to know it. So I think I passed that out, just like out of the plotting function, stuff like that.
And we should probably just move this to the utils, right? To the plot utils. And since we're going to have a standard format of record the inversion, then we just pass it over.
Yeah, that's an option.
mm-hmm.
Then I'll start the PR, and then we can all pitch in.
Sounds good.
Anything else?
Not really on my end.
Soggy, if you could stay on after that, there's one thing that I'd like to get to talk to you and Dom.
Okay.
Just to kind of go through and make sure that we've got all of the notebooks as well as all of the figures that we want to use, regarding potential fields, that we have everything kind of at hand for the course. I think we're pretty good there, but you've been still filling in some of the figures, and we've got a revised 3D inversion for the magnetic. I think it'd be just nice to kind of go through the various elements of the course and just see where DOMS, where the potential fields is really coming in, and where we actually have got all of the results developed through SimPEG.
Yeah, sounds good. I do have a time, so.
On this, maybe we can close the meeting today. One last chance to say something or be quiet till next week. All good?
Thanks for leading.
Okay.
I got 2 more beers ready for next week, so I'll see you Tuesday.
Oh, well, can you deliver to California?
I'll be there at the end of the month.
I'll meet Lindsay and enjoy with her.
Sounds good.
I'll try to bring some when I come down.
Sounds good.
See you guys.
See ya.
Bye.